This conference will now be recorded.
Are you able to see my screen?
Yeah.
So what is class? What is object we have discussed, right?
Yes.
And how to access that, all those things we have discussed.
No.
Okay. This one, this example.
Not covered. Not covered.
Okay.
Only the definitions covered.
So what is class?
Class is a collection of variables and functions into a single unit.
What is a object?
Object is an instance of class.
So what is the purpose of object?
Object
What is the purpose of object? This is basically meant for accessing the components of a class. Okay. Got my point, right? Hello. Yeah. Yeah, you can speak it out. Amen.
okay.
Okay, that's what. If you need to invoke any particular component of a class, you can take the help of this particular object. Is that clear?
Yeah.
Now, let me show you how that particular class will be there, how the object will be there, how to access that, all those things. We are going to say that now. Okay, now? Are you able to see my screen?
Yes.
See, this is what a class. The class name is student. Within the class, we have got one function whose name is display. Is that clear?
Yeah.
Yes or no?
Yes.
Next. Remember one thing, already we have seen the concepts of functions, where right now we are going to see the functions within the class. Functions within the class in the sense, those functions, all the functions of a class, all the members of a class need to take one parameter, that is what called as self. Is that clear? Yes or no?
Okay.
All the functions of a class need to take one parameter, that is what called as self. See, to denote that this is a member of the student class, here we are providing tab space. That means this student class is holding display function. Okay, now?
Okay.
At the same time, it is taking on parameter self, which denotes that this display function is member of student class. Okay.
Hmm. Okay.
What this display function will do? Display function, it is just printing simple student. You can check it out. This display function, it is printing simple student. Now, as usual, we have got a class, we have got a function. It is taking self as a parameter and it is printing simple student. Clear, right?
Yeah.
Okay. Now, like other technologies, if you take any C, C++, Java, whatever the technology, even here also, if you need to access a member of a class, what we have to do is we have to create an object for a class. Let me comment this one. For commenting, you have to use hash as an operator.
Okay.
Hash is an operator which will be used for commenting that particular line. Remember this point. You know? Yes or no?
Yes.
Hello.
Yes, Swaroop.
Hi, Ryan. Hello.
Yes.
Uh, yes, they said that they're going to take a demo class from me now.
Yes, that's what we have started just now.
Okay.
Yeah. Okay. No? Okay. Now, as we have got a class student, we have got a function display. Within that, we have got print statement. Not only print statement, if you want, you can have your own business logic available within that particular display function. Now, how can we call that particular display function? That is what we need to know right now. Basically, if you need to invoke any particular function of a class, we can invoke in two different ways. One is this way. Let me show you. This is the way. S equal to student. That means S is one object. What is meant by object? Object is nothing but reference of a class. Otherwise, you can call it as variable of a class. Basically, you might ask a question. What is the purpose of this object? How this will help us? You might ask a question. The purpose of object is to
To access
invoke
the
the member of a class. We will take the help of object. Is that clear?
yes.
To invoke any member of a class. Invoke in the sense it is just like calling. If you need to make it work, if you need to make it perform certain operations, you can take the help of this particular what do you say, object.
Object.
And object is user defined value. There is no rule like it should be yes only. You can give whatever the value you want over there. Okay, na? Yes or no? Is that clear? Hello? Okay.
Yeah, yes.
Yeah. See, yes is an object for the student class. It is just like for a room, how we will be having a key to access the components available within that room. Here, we will take the help of this particular object to access the components available within the student class. Okay, na?
Okay.
Now, once you got a key for this particular student class, that means object. Once if you got an object for the student class, with that particular object, see this object dot display. I'm calling display function. Whenever I call display function, control will get transferred to student class display function. What this display function will do? It prints simple
Yes.
student. You can see the result. If I run this, it displays simple student over here. Okay, now?
Okay.
Any doubts so far?
No doubt.
Okay. Next. This is one way. Here, in this way, what we are doing, we are creating a specific object. With that object, we are calling a specific function. But in the next case, we won't be creating object. See here, this case, we won't be creating object. Directly, student.display we are doing. Even this way also can be invoked. You can see, if I run this, automatically the student class display function we are invoking. Okay, now?
Okay.
Yes or no?
Okay, but what is the difference between those two?
Yeah, that's what.
For
That is what one important interview question. Whether this one is a good way, otherwise this one is a good way. They'll ask in interview.
for better understanding, the first way is good, I guess.
For better understanding.
Huh.
Okay.
But when we are working on some big program, the second method is suitable
Okay.
if you
Fine.
are familiar with code.
First way is good.
Or if you have many.
Let me tell you why that will be good in the sense. Let's say in our class we have got some 10 functions. Okay, no? All that 10 functions we can call by taking the help of this single object only. S dot display, S dot display 1, S dot display 2, like this. You can call all the functions at one stretch. Got my point, right?
Mm.
whereas only one object will get utilized. Only one object will get wasted for all that particular 10 function invoking. Got my point, right? Yes or no? Are you guys with me?
Yes, yes.
Yeah. Only one object will be wasted. That means, let's say here I have created object yes. With that yes object only, I can call display, display1, display2, like this. 10 different functions I can call it. Let's suppose if you go in this particular way, student.display, student.display1, display2, like this, how many ever times student bracket you are using, that many memories will get wasted. Remember this point. Okay, now?
Okay.
That much memories will get wasted. So instead of wasting so much memory and degrading the performance of your project, you can take the help of the first way and you can save your memory. Okay, na?
Hmm.
Any doubt so far?
No.
To everyone. Is that clear?
Yeah, it is clear.
Yeah. Next. I'll go for next one. See, in previous example, we have got one function which is not taking any parameter. As I said, self is a default parameter to denote that it is a member of the class. Okay, na?
Okay.
Where you should not consider self as a parameter. Now, how to pass the parameters to a function? How to perform some operation? Let me show you right now. You can see here we have got display function. It is taking two parameters, a and b. It is printing sum as well as a plus b values. Now, how we can call this particular function? See, we are creating an object for this class. With that object, we are calling display function. N will be assigned to A, 20 will be assigned to B. This will print sum A plus B. Either you can go in this way, otherwise you can go in this way also. See, the result wise it is same only, sum 30. Okay, now?
Okay.
Is that clear?
Yes.
Okay. Now, ready? Inheritance. Inheritance. It is a process of it is a process of deriving the characteristics from deriving the characteristics from existing class to existing class to new class,
Sorry.
existing class to new class is called as inheritance. Got my point, right?
Yes.
Next, types of inheritance. There are five different types, five different types of inheritances available. Available. Those are okay. Right? single inheritance. Okay, na?
Okay.
Single inheritance. Read about single inheritance.
Hmm.
Single inheritance. It is a process of deriving the characteristics from one base class to one derived class, one base class to one derived class. Then it is called as single inheritance. Okay, na?
Okay.
See, basically, our object-oriented programming language nature and intention is reusability is what the important things what we have to consider. Okay, na?
Okay.
That means one simple code and how many ways we can reuse it, in how many places you can use it again and again is what the important logic behind our object-oriented programming language. Not only Python, you can take Java, C++, whatever the technology it is. If object-oriented programming language is there, in the sense, the major intention, major usage behind that is reusability only. Remember this point. Okay, no? Yes or no?
Okay. Yes, yes.
Next, when it comes to our this particular inheritance. Inheritance is also one of the important feature which we have to consider for reusability in our object-oriented programming language. Let me take how this particular inheritance will be there. Okay, no? Now, the inheritance major agenda, major usage is reusability. I said here already a class is there. First, I am speaking about single inheritance. Already a class is there. Someone has designed the class, and some logic is there within that particular class. Okay, no? Now, if you want same logic for your program, instead of you developing the same code again, what you can do, you can ask his permission and you can derive the features from him. Got my point, right?
Mm. Yes.
So that reusability enhancement can happen. Let's say you take an example. Some person has developed normal bulb. Got my point, right? Edison has developed a normal bulb long back. Got my point, right?
Mm.
Where whatever he has developed, other next generation people, what they have did, they have derived the features of that particular bulb and they have enhanced and they have created some tube light. From tube light, next generation, they have enhanced it to LED light, some other lights and all. Got my point, right?
Yeah.
Yeah, like this, the knowledge what Edison was having that we are deriving and we are enhancing it. Let's suppose if Edison he is not sharing his knowledge, if he is not sharing the knowledge, then what will happen? Again, current generation also they have to start their invention from normal bulb only. Correct, right?
Yes, yes.
Yeah. So here in this thing, if you observe reusability, that means one code or one concept, whatever one person has developed, that we will be reusing it in another program. So that we can enhance it. We don't need to work out on the logic what he has developed already. We can enhance it to next level of code. Clear, right?
Hmm.
And here, if you just observe, if you are deriving the features from, that means if someone has developed a feature from one particular person, if you are deriving the features to another program, then it is called as single inheritance. Okay, no?
Okay.
We are deriving the features from one base class to one derived class, then it is called as single
Single
inheritance.
inheritance.
Is that clear?
Yes.
Hmm.
Now, what is this?
That
What
is
is
the
this? Sorry?
existing class.
Yeah,
Base class.
that is what called as base class. Right now, definition of base class. The class which provides the characteristics. The class which provides the characteristics is called as base class. Okay, na? Find it? Hello?
Yeah.
Hello.
Yeah. Next, write a derived class. The class, which acquires the characteristics, from the base class, then it is called as derived class. Okay? Any doubts so far?
No.
Okay. Here, if you observe single inheritance, we have got only one base class as well as one derived class. How this particular base class and a derived class will be there, we are going to see right now. Okay? Yes or no?
Yes.
Yeah.
If any background noise is there, you can mute it better so that recording session won't get disturbed. Okay. Now, how this single inheritance will be there? Let me show you right now. Okay.
Mm-hmm.
Where is the single? Yeah, here. Now you just see this one. We have got one class with the name base. Okay,
Base.
now? And this base class is having get a function which is returning 10. Is that clear?
Mm-hmm.
And the same base class is having one more function get
Get B
b
function.
which is returning 20. That means someone has defined a class and they have defined the logic
Two
also
function.
within that particular class. Okay, now? Yes or no?
Yes.
Now, in your class, you want that particular class features. In your class, if you want that particular class features, what we are doing, class derived base we are mentioning. That means this is what your derivation. It is just like father and child kind of relation. This class will act like a father for this particular derived class. Okay, na? Yes or no?
Yes.
Now
Yes.
we are deriving. So whatever the functions available in the base class, like get a function, get b function, it is just like if you don't have money, your father have money, you can take his help and you can take the money from him, right? Yes or no?
Yes.
Same way here also, see, we have got some function self dot get a. Whenever you are calling get a function, first you will look for get a function in your own class. Is it available? No, it is not available. By seeing this, control will go to base class. Here get a function is there which returns 10. Okay, now? Yes or no?
Yes.
Next, we are calling plus self dot get b. Whenever you are calling get b function, again control will look for get b function in its own class. It is not available. By seeing this, control will be transferred to base class. Okay, now? Here, if you check it out in the base class, we have got get b function. Okay, yes or no?
Yes.
What this get b function will do, it returns 20. So totally 10 plus 20, 30 will be printed over here. Okay, now?
Mm-hmm.
Now, you can see for a derived class, I am creating an object. For a derived class, I am creating an object that is D. With that object, I am calling some function. This sum function internally calling get a as well as get b, so that result will be 30.
30.
Clear, right, everyone?
Yes.
Ramesh?
Yes, yes. But
Yeah.
is it mandatory to use the self keyword in the
Yes, the
derived
self
class?
keyword is mandatory. Everywhere self keyword is mandatory. Remember this. Without that self keyword, it will be considered as not member.
Okay. And one more thing.
Hmm.
Uh, Here you are creating the object for a derived class
Correct.
and printing the sum. Uh,
Hmm.
what if we can in the base class elements, which will print first? The first base class or a derived class?
Sorry, sorry. If you
If you want to print the data from both the classes, from base class as well as the derived class,
based on the
which
invoke,
output?
which function you are calling first.
Okay, okay. Depends on that, we'll get the output.
Correct, correct.
Okay.
Clear, right?
Yes.
So if
Okay.
the base class and the derived class, if both have the same function,
Hmm.
what will happen at that time?
That concept will come later. That is called as function overriding. I'll
Okay,
speak
okay,
about that concept later.
okay,
Okay, then?
okay.
Yes, yes, yes. Yes, Narendra.
I'm asking one thing. This is a demo class.
Yes, Narendra.
When the class will started? Like because just now I joined, so I don't
Half an
understand
hour
that.
back, it got started. Half an hour back.
Half an hour back. That's why it's everything is new for me. Okay.
Yes, you can listen just for today. Later we can speak about this. Okay?
Okay.
Yeah, fine. Now, uh, now here one important question what we have to consider is for which class we need to create an object, either for base class, otherwise for derived class. You can see this is what your base class, this is what your derived class. For which class we should create an object is what the important question.
For the class which you want to call.
Not like that. Basically, for most derived class, you should create an object. Remember this point.
Okay.
Got my point, right?
Okay.
See here. This is base class. From this class to this class, we are getting the features. So, if you create an object for this class, you will be able to access only this class features. Okay, na?
Yeah.
When
Okay.
it comes to this class, if I create an object, I can access this class features as this class is getting the features of this class. We can access this class features also.
Yes.
Yeah,
Okay.
right?
Yes.
So, whenever you are creating an object, make sure you are creating an object for most derived class. Okay,
Okay.
na? Yes or no?
If you have one more derived class, in that case, the last created derived class, from that only it will use that.
Yes, yes, yes. That concept we will be seeing next. Okay, na? Yes or no?
Okay.
Yeah. Okay.
Okay. Now write down next type of inheritance, that is hierarchical inheritance. Hierarchical inheritance. It is a process of deriving the characteristics from deriving the characteristics from one base class to more than one derived classes, more than one derived classes, then it is called as then it is called as hierarchical inheritance. Okay, no?
Mm.
Now, here, if you observe this single inheritance, we have got one base class, one derived class. That means one parent, one child. If you go for hierarchical inheritance, one parent, multiple childs. Okay, no? How many ever it is, that is, there is no limit for that. We can connect multiple childs like this. Got my point, right?
Yeah.
Uh, Now, this particular class features can be utilized by all these derived classes. You can see by all these derived classes. This features we will derive it over here for addition. This features here for subtraction, division, multiplication, like this. That means one person he has utilized the features for one operation. Another person same features you will utilize for some other operations. Got my point, right?
Yeah.
Like this, we will take the help of hierarchical inheritance. And if you observe this hierarchical inheritance, how many ever derived classes are there? For all the derived classes, we will create object. Previously, one only derived class was there. Right now, we have got multiple derived classes. Got my point, right?
Yes. Yes.
For all the derived classes, we will create object. Is that clear so far?
Yeah.
Everyone. Swaroop, Sashi,
Yes, sir. Yes, yes.
yeah. Now let me show you how this hierarchical inheritance will be there. Okay, na?
Okay.
Okay. Now can you see this?
Yeah.
Here we have got one base class which is having get a function and get b function.
Okay.
Yes or no?
Yes.
Now, same base class, I am deriving it to class add. See, for class add, I am deriving base class to perform sum. Self dot get a. That means from here get a function. Self dot get b. From here get b function. Both I am retrieving, performing addition and printing the result. Clear, right?
Yes.
Next, say for this to this we have derived. From this to this we are deriving performing subtraction. Self dot get a minus self dot get b. Got my point, right?
Yes.
So from same base class we are deriving it to two derived classes for performing various operations. One is for addition, one is for subtraction. Now for first derived class I am creating object, I am calling sum function. For second derived class I am creating object, I am calling sub function. Yeah, right? Yes
Yes.
or no?
Yes.
Hmm. Now you can see the result. 30 you got from add, minus 10 you got from
Minus.
sub. Clear, right?
Yes.
This is how you are hierarchical. One base class, multiple derived classes. There is no rule like only two derived classes will be there. You can go for n number of derived classes over here. Got my point, right?
Okay.
Yeah.
And also fun?
No.
Okay. Can I go for next one?
Yes.
Next. Right? Multi-level inheritance.
Multi-level.
Yeah, multi-level inheritance. It is a process of it is a process of deriving the characteristics from deriving the characteristics from derived class itself. Derived class itself.
Derived class.
Derived class itself.
Okay. Okay.
Derived class itself.
Okay.
Then it is called as multi-level inheritance. Okay, na?
Okay.
Now that means see from a parent to child. Okay, na? From this parent we are deriving to this child. From this child we are deriving it to another child.
Okay.
Like this, how many other levels you want, you can derive it. Got my point, right?
Yes.
Hmm. Finally, which is the last derived, for that we should create object. Okay, na?
Okay.
That is what multi-level inheritance is all about. Yes or no?
Okay. Yeah.
Now, how this multi-level inheritance will be there, we are going to see right. Okay, na?
Okay.
Hmm. See, we have got a base class. Okay, na?
Hmm.
We have got a base class. From base class, I am deriving the characteristics to derived class. Okay, na?
Okay.
Here I am performing addition and returning the value. Got my point, right? Next,
Yes.
from derived class, I am deriving it to last derived. Here I am performing average. Got my point, right?
Hmm.
Whichever is the last derived, for that I am creating an object. See, for last derived, I am creating an object LD. I am calling AVG function. AVG internally calls sum. Sum internally calls get A and
Get
get
B
B.
from
So
base
10
class.
plus 20, 30 will be returned here. 30 will be reached to this. 30 by 2, that means 15 will be the result. Clear, right?
Hmm.
From this class to this class to this class, we have got the feature. That's why this is called as multi-level inheritance. Check it out. The result. Yes or no?
Yeah.
Any doubts so far?
No.
Okay.
No.
See, here I have taken 3 levels only. From this to this to this. There is no rule like 3 levels only. Sometimes what will happen? We will be having more than 3 levels also. Got my point, right?
Yes.
Even that also can be considered as multi-level inheritance. Okay, na?
Okay. So, can we define a class for the derived class as well?
Yes, you can define a class.
But to print the output, you have to, in the place of return, you have to give print, right?
Correct, correct.
Okay.
Okay, na?
So what? So if in place of return, if we give print now, what will happen? Will we get the exact output, the accurate output, or no?
Where here?
Yes, here in place of return.
Here, if I use that won't reach here, you will get error here.
Okay, okay,
You will get the output from here itself. 30.
okay.
Clear, right?
So if we give print there, and if we define a class for the last derived class, so we are going
Hmm.
to get an error, or we are going to get the output.
We will get the output till here only. This will not generate any output
Okay. This won't generate any output. Okay, okay.
because nothing has returned to this function, right? So only.
Okay, I understood. Thank you.
Yeah. Now, read about next type of inheritance, that is multiple inheritance.
Multiple.
Hmm. Okay, now
Okay.
multiple inheritance. It is a process of it is a process of deriving the characteristics from more than one base class to one derived class. Then it is called as then it is called as multiple inheritance. Clear, right?
Okay.
Now, see, it is just like previously what happened. This was a hierarchical inheritance. Hierarchical we have seen, multi-level we have seen. Now, multiple means multiple base classes will be there. One derived class will be there. Clear, right? Yes or no?
Yes, yes.
Yeah. This is what your multiple inheritance, where from multiple base classes, we will derive the features to one derived class.
One derived class.
Hmm. Now, whatever the features are there from all the base classes, we will get it derived to one derived class and we can utilize it for the purpose however we want. Clear, right?
Yes.
Now, how this multiple inheritance will be there, we are going to see right now. Okay, na?
Okay.
Now, here we have got base 1. You can check it out. Base 1 is having get a function. Okay, na?
Okay.
Which is having get a function, where that get a function is returning a value that is 10. Okay, na?
Okay.
Next, we have got base 2, which is having get b function and it is returning 20. Got my point, right?
Yes.
Need out so far?
No.
Okay. Next, you can see add class is there, which is deriving the features of base 1 and base 2. Okay, na?
Okay.
Add class is deriving the features of base 1 and base 2.
Okay.
What this is doing, it is calling get a function which is from base 1, get b function which is from base 2. So both will be performing addition and printing the result over here.
Okay. So if base 1 and base 2 have the same functions, get a and get a.
No, as per the rule, you should not create that kind of functions.
Okay.
But suppose if you have created, then we have to call it with a class name. That is different concept is there that I'll show you later when that
Okay.
situation comes into picture.
Okay.
Got my point, right?
Okay. And in the add class, we have defined some function, right? And why are we only giving one parameter if there are more than one parameters, like self, A, B, C?
Which one
In the add class, we have defined some function, right? And we have
yes,
only defined one parameter, the self parameter.
correct.
So
That
if
self is basically meant for denoting that it is a member of that class. That's it. We are not taking
okay,
any parameters over here.
okay, I didn't understand the meaning of member of a class. So,
Now, basically, if you need to denote any class as a any function as a member of a class, that function
okay,
should take self as a parameter.
okay,
If it is outside function in the sense, you don't need to pass that self parameter.
okay,
Yes or no?
okay, okay,
All the class members need to have one identification. Just remember like this. Need to have one identification, that is self.
Okay.
Without self, that won't be considered as a member of a class. That's it.
Okay.
Get out so far?
No.
Okay. So here the output will be
30.
30.
okay. Can you open next one?
Yeah.
Yeah.
That one, hybrid inheritance. Hybrid inheritance. It is a combination of all the four types of inheritances. Then it is called as hybrid inheritance. Okay, na?
Okay.
That means whenever if you are combining all the four types of inheritances and if you form one inheritance, then that will be considered as hybrid inheritance. Okay? Yes or no?
Okay. Yes.
Yeah. How this hybrid inheritance will be there? Let me show you right now. See. First, let me show it to you through a diagram. Then understanding will be easy. Okay, na?
Okay.
See. You can see this one. Here, this one is an example. The structure is meant for hybrid inheritance. In this, if you just check it out, this is your single inheritance. This one is your single inheritance. This is your single inheritance. Like this, four single inheritances are there here. Got my point, right?
Yes. Yes.
Mm-hmm.
Yes. Next, if you go with this way, this is multi-level inheritance. This to this, this to this. Otherwise, if you go in this way, even this is also multi-level only. This to this, this to this. Clear now?
Yes.
Next. If you go for this 3, this is hierarchical inheritance. One base, two derived classes.
Yes.
Okay. Now, if you go with this, let me show you next way. If you go with this 3, this is multiple inheritance.
Multiple inheritance.
Clear, right? In this, all the four types of inheritances are there. That's why this is called as hybrid inheritance. Clear, right?
Yes.
Yes or no?
Yes.
Yes.
How this hybrid inheritance will look like, all these things in tomorrow's session I'm going to explain in detail. Clear, right?
Okay.
Tomorrow exactly 9 p.m. IST we are going to meet up. 9 p.m. IST, that is what. Okay.
9 p.m. IST.
Yeah, 9 p.m. IST. That's what. How you have joined today, same way you can join tomorrow also.
Okay. Okay.
Yeah, fine.
Okay.
Hmm.
Thank you.
Bye.
Bye. Thank you.